Hello, y'all. Welcome to lesson 108 of my DP chemistry curriculum. Today we're doing reactivity 3.2.3 and 4. In 3.2.3, we'll discuss the relative ease of oxidation and reduction of an element in a group that can be predicted from its position on the periodic table. The reactions between metals and aqueous metal ions will demonstrate the relative ease of oxidation of different metals. We'll be able to predict the relative ease of oxidation of metals. We'll be able to predict the relative ease of reduction of halogens, and we'll interpret data regarding metal and metal ion reactions. Furthermore, in 3.2.4, we'll talk about how acids react with reactive metals to release hydrogen, and we'll just discuss that equation. So we'll deduce those equations specifically. So we're going to start out with relative ease of oxidation of metals. Now, when we look at metals, we'll look at pretty much any metals, but we can see that some metals oxidize more easily. Some examples might be like iron, copper, silver. You'll notice these rust or tarnish. And that's representing the oxidation reaction as they react with air. And so we can see that they are more likely to oxidize. Some metals are less likely to oxidize and do not rust or tarnish. And in those cases, those have a harder time oxidizing, or their relative ease of oxidation is harder. Now, when we take a look at two metals together or compared to each other, we can see an oxidation reaction or reduction reaction happening in certain scenarios. So, for example, if I have a solution of maybe copper sulfate, and copper sulfate is blue because the copper 2 ion is blue, and I take that and I drop in some zinc solid. Over time, this solution will look a little different. We'll notice that on the zinc, we will start forming solid copper. So Cu solid will form. Furthermore, this solution, which was once blue, will actually lighten up a little as copper is pulled from solution. So it will still be copper sulfate. But now we're also going to have some zinc sulfate. And this copper sulfate is less concentrated because it's being pulled out and it's precipitating onto the zinc. This tells us a couple of things. First off, this is what we would call a displacement reaction. The displacement reaction is where the more reactive metal displaces the less reactive metal in a compound. So in this specific instance, zinc is reacting with copper sulfate, and the zinc is displacing the copper, creating zinc sulfate, aqueous, and solid copper. So here we see that zinc displaces copper in the sulfate. And so we can tell that therefore zinc is more reactive. Now, if we start looking at oxidation states, zinc has an oxidation state of 0, copper has an oxidation state of +2. Now, zinc in the products has an oxidation state of +2, while copper is 0. So zinc oxidizes while copper reduces. Therefore, zinc is more likely to oxidize because it does. What we know about metals as a whole is that metals tend to lose electrons and become cations, which is just another way of saying they tend to oxidize. And so if they have a higher tendency to oxidize, that also means higher reactivity. So higher, or we can say it the other way, higher reactivity means easier to oxidize. And so we can see that zinc is more reactive because it is oxidizing in a copper solution. Just for the inverse, if we took a solution of zinc sulfate and we put some copper in it, nothing happens. We get no reaction because copper is less reactive than zinc and will therefore not displace it. The last thing we can say is that because zinc is oxidized, we can also say zinc is a stronger reducing agent than copper. So just using all our vocabulary, zinc is more likely to cause something to reduce than copper is because zinc caused copper to reduce but copper did not cause zinc to reduce. Now, for metals, the general trend is the same trend we looked at in the metallic continuum videos. If we have our periodic table with our semi-metals, non-metals, metals, this is more reactive as we move down into the left. Therefore, that is also easier to oxidize. This is a general trend, not a surefire rule, but in general, the further you move towards francium, the more likely a metal is to oxidize. So that covers metals. What we're going to go over next is relative ease of reduction of halogens. Now, we could talk about all nonmetals, but we're going to focus on the halogens. We know that halogens tend to gain electrons, which is just another word for reduce. When they gain electrons, they reduce. Now, that trend follows electronegativity. So we can see that we're going to increase in reactivity slash we will increase in ease of reduction moving up towards fluorine, with fluorine being the most likely to reduce. That's about it for halogens. So this is pretty much all you need to know about the ease of oxidation and reduction. In your chemistry class, you will likely do some type of reactivity series experiment to demonstrate this. But moving forward, the last thing we're going to do is talk about reactions of metals with acids. Now, when we're looking at metals with acids, for example, magnesium plus some dilute hydrochloric acid, the one thing you can always form is your salt. So in this case, we have MgCl2 causing us to balance this, plus hydrogen gas, whoops, H2 gas, And this is generally what happens with most metals with acids. What we see here is that our magnesium oxidizes to form Mg2 plus. Meanwhile, our hydrogen reduces to form hydrogen gas. So the general formula for our metals with acid, general formula, is going to just be metal plus our acid reacts to form salt, which is just your metal plus acid anion plus hydrogen gas. And you'll generally be able to test this by doing like a hydrogen popping experiment or putting a burning piece of wood into your reaction vessel and you'll burn the hydrogen. You'll get a little pop. So hopefully this helps you understand a little bit about the ease of oxidation and reduction in metals and nonmetals, specifically the halogens, as well as gives you an idea of what happens when metals react with acids. Uh, this is about it for these two sections, and have a great night.